After over 5 years of research and development, we're proud to release the Impulse IQ adjusting instrument. I'm Dr. Chris Colloca, CEO and founder of Neuromechanical International, and the inventor of the Impulse adjusting instrument and its most recent version, the Impulse IQ. In this video, I'll introduce you to the technology behind Impulse IQ so you can understand why we've developed it and teach you about its functionality and performance. I'll also walk you through how the instrument works so you'll know how to use it right away, so you can get the best results with your patients and explain it to them in terms that they can understand. Let's begin with its functionality so you know how it works and what it does. Impulse IQ has a sensor embedded in the nose piece of the instrument, which is an accelerometer that precisely measured spinal motion. The sensor is connected to a computer microprocessor that controls the functionality of the device. So when Impulse IQ is applied to the spine, or even the extremity joints for that matter, the instrument measures the acceleration response simultaneously during the adjustment. Very simply stated, we're interested in two very basic variables during the adjustment. How much did the bone move, and at what speed is it moving? If we know how far the bone moved, we can differentiate joint fixations as opposed to hypermobile segments. And we can have the instrument stop when mobility has been maximized. In fact, we define the adjustment as maximizing mobility. So the instrument can sense when motion is maximized and automatically cease firing at that time. If we know how fast the bone is moving, we can tune the frequency of our multiple impulse thrusts to that speed so that we can get more bone movement with less force. You can think of the adjustment at the right frequency as being in tune with what you know about frequency at which the structure is naturally moving. So, Impulse IQ was designed to detect the spine's motion and speed during the first thrust, which subsequently sets the frequency of the subsequent multiple impulse pulse trains during the adjustment. And the instrument then shuts off automatically when mobility has been maximized. In real time, the instrument's frequency will change in response to what the spine is doing. So during the adjustment, as you are thrusting and the muscles are relaxing and the joint's mobility is increasing, the bone will move faster, and IQ senses it. So how did we come up with this technology, you may wonder? Just like its predecessor, the Impulse adjusting instrument, Impulse IQ was born out of research. I feel that it's important to tell you a bit about Impulse because its features were carried over into IQ. You see, Impulse was initially developed to improve the efficiency of chiropractic adjustments and solve the problems that many chiropractors had with instrument adjusting. That is, that their hands hurt from having to squeeze spring-loaded instruments all day. So Impulse was designed to be light in weight with an electronic trigger mechanism that's easy to pull with your index finger, causing no undue stress on your wrist or hands. We added a preload indicator light which turns from red to green when proper preload or tissue pull is achieved. So you know how hard to press the instrument into the patient prior to adjusting. Next, we improved the range of forces that Impulse could produce from a light force of about 100 newtons on our low setting, which is ideal for adjusting the upper cervical spine or excessively tender areas, or even pediatric or geriatric patients. Impulse's medium setting produces about 200 newtons of force, which we use on the thoracic spine, the lower cervicals, and the extremity joints. Our high force setting is about twice as much force as a spring-loaded activation device that we suggest only be used on the lumbar spine and pelvis of adults. This high setting produces 400 newtons of peak force, which isn't low force at all. This high force setting is analogous to peak forces used for lumbar adjustments that are done manually. But with the instrument, it's easier on you and easier on the patient. My co-inventor, a renowned biomechanist, the late Dr. Tony Keller, had tried for years to improve the thrust profile of spring-loaded devices, which led to several iterations, a version 2, a version 3, and a version 4 of those devices before finally giving up. You see, the thrust profile that Tony desired, we found could only be optimized by going electric and using a computer program to produce the half sine wave that Tony was looking for. You see, research has shown that this waveform was ideal for exciting the broadest range of frequencies during an adjustment, which is important for not only how much the bone will move during the adjustment, but also stimulates a broader range of frequencies or mechanoreceptive nerves that play a role in inhibiting nociception and subsequently reducing pain, relaxing hyperactive muscles, and reducing sympathetic hyperactivity. We program the individual thrust of impulse to be at the right speed for maximizing motion, which is twice as fast as other adjusting instruments. We then put this to validation in our research studies, and we found that both in our bench test experiments and in live studies of bone movement, the vertebrae moved better on all 4 settings using impulse, because of the extreme speed of each individual thrust that's given with this specific waveform. Our research was the first to measure vertebral motions during multiple impulse thrusts. And from this work, we set the rate of thrust with impulse to be 6 times a second, or 6 hertz. This thrust rate is what we found to be ideal for maximizing the mobility of the spine, because it targets the natural or resonant frequency, that frequency that the spine moves best. As you know, our patients are of both genders, they're different age ranges, different degenerative status, and we also have different regions to adjust, from stiff lumbars to very mobile cervical spines. So impulse was created to target the average speed or the average frequency for all of these variables in a lower price point device. You see, without a sensor, we can't measure each individual's distinct motion pattern anyway. That is, until the invention of Impulse IQ. The advancements in sensor design and microchip technology allowed us to develop a new way of identifying spinal motion responses, giving rise to Impulse IQ. So we have a line of chiropractic adjusting instruments at 2 price points: Impulse without the sensor, and our latest invention, Impulse IQ, which carries the features of Impulse over to this new exciting technology. What we found in our research is that multiple impulse thrusts could increase spinal motion by up to 25% compared to single thrusts alone. We validated our measurements by comparing what we measured with our instrument to pin-mounted accelerometers that were rigidly affixed to the spinous processes. This way we could be sure that our protocols were research-based. In a series of research experiments, we determined the effects of several variables that we then incorporated into the design of IQ. We published our results on how the forces and speeds of chiropractic thrusts influence bone movement and neuromuscular responses in the journal Clinical Biomechanics in 2006. We published data on the effects of spinal motion and stiffness at different speeds and different multiple impulse rates or frequencies in the Journal of Biomechanics in 2007. We showed how muscle influences the dynamic spinal stiffness and changed the frequency of motion, and published this in the European Spine Journal also in 2007. We were also able to demonstrate how disc degeneration reduced vertebral motion responses that same year in the prestigious journal Spine. And in 2008, our research on how disc degeneration affects the paraspinal muscles and spinal nerve roots is published in the Journal of Electromyography and Kinesiology. Yes, that's a lot of research, but that's what you should expect from your medical device manufacturer. Indeed, what we learned was what was necessary, just how the spinal joints moved under these different clinical situations that we see every day in clinical practice. All of this research and more thus went into the development of Impulse IQ. Before I give you a demonstration, let me tell you about the audible indicator that we've incorporated into IQ as well. Following successful adjustment with Impulse IQ, you should hear the instrument beep once. When you apply Impulse IQ to the spine or extremities, it will begin thrusting at a rate determined from the initial thrust. The computer algorithm inside the instrument processes and analyzes the data and looks at the amount of the acceleration response and the frequency of that response, and in turn sets the pulse train rate. As the area is being adjusted, the motion response changes as the joint becomes more mobile and the muscles relax. The instrument's AutoSense technology senses this and increases the pulse rate of the instrument to keep up with the frequency of the new motion pattern. The program also assesses the motion response of each peak and compares them to previous ones. So when mobility is maximized, the device will stop firing, and you'll hear the instrument beep once. Your patients will notice this change in speed, and you can educate them about what the instrument's doing during the adjustment, speeding up to keep up with your new adjusting pattern. You'll find that your patients will be excited about this technology as you are. Following the single beep, we recommend that you still check your clinical indicators that necessitated the adjustment before you move on to the next area. Now, if Impulse IQ beeps twice after the adjustment, this means that maximum mobility has not yet been reached, despite the pulse train. We built this feature in as a safety precaution, so if maximum mobility isn't sensed after 36 pulses, the instrument will cease firing and you can reassess the situation. Now, it could mean that the area can continue to be adjusted further if you're sure that your contact was good, or it also could mean that you didn't hold a good enough contact and the adjustment didn't sense maximum acceleration response yet. So when you hear two beeps, recheck your clinical indicators and determine if more adjustment is necessary or not. Now, if you don't hear a beep after the initial series of pulses when you're thrusting, this means that no significant improvement in acceleration response has been detected. It could be that your contact point is wrong or that your line of drive is off. So be sure to check those things before reapplying the instrument. Also, you may find that this specific area of the spine is not going to increase in motion. It could be a degenerative area or a patient with excessive muscle spasm that just isn't going to change. So when you don't hear a beep, your options are to reapply the instrument to the patient's tolerance and readjust after checking your segmental contact point and line of drive, or move on to another area, which may be an adjacent segment. You'll have to use your own clinical judgment in terms of this. Another scenario is when the instrument's pulse rate actually decreases. So an initial faster rate pulse train slows down during the adjustment. When you observe this happening, consider that the thrust is causing the patient's muscles to guard and resist the adjustment. You may want to consider changing the force setting or your segmental contact point when this occurs, so it's not irritating to the patient. Remember, Impulse IQ does not set the force of the thrust ever. The force of the thrust always has to be set by the doctor prior to applying the instrument to the body. So always adjust the instrument to the patient's tolerance despite feedback from the instrument. For example, if you're adjusting the lumbar spine with the high force setting and you notice that the patient is uncomfortable, stop the adjustment by letting go of the trigger. You may want to use a lower force setting in this case, or determine not to adjust that area at all on this visit. Use your own clinical judgment. Remember that Impulse IQ has a sensor to give you the feedback from the adjustment in real time. Thus, the results are only as good as the operator holding the device. So don't be sloppy with applying the instrument to the patient. You must make your contact well and hold a firm grip so that the sensor can get an accurate read. If you don't hold the device with consistent preload, your reading will also be off. So preload the nose piece until the spring is compressed and hold the device in that position as you make the adjustment. You'll get the hang of it with practice. Just like Impulse, Impulse IQ features an electronic trigger, a preload indicator light, 3 distinct force settings that are driven by microchip technology, and interchangeable single and dual styluses. Let's tell you about the benefits of these features. You'll notice that upon plugging the instrument into the wall, the LED will turn red, signaling that you have power to the instrument. If you pull the trigger, nothing happens unless the nose piece of the instrument is compressed for preload. Have you ever wondered how hard to press prior to adjusting? Well, our preload indicator light will turn from red to green when you've achieved the proper preload, signaling that you're ready to adjust. With the LED green, the instrument will now fire at your selected force setting when you pull the trigger. Understand that prior to adjusting, pressing too hard into a patient can reduce the amount of bone movement that will occur and be uncomfortable to a patient. Conversely, by not pressing hard enough, it will cause the force to be absorbed by the soft tissues rather than the target vertebra. Research has shown that about 20 newtons of preload is utilized by chiropractors performing manual adjustments of the spine. An impulse is equipped with a 20 newton preload spring in the nose piece of the instrument that's ideal for just the right amount of pressure or tissue compression prior to adjusting. Impulse IQ has 3 distinct force settings, just like Impulse, low, medium, and high, that are achieved by means of a 3-position switch located just above the handle grip. Selection of the appropriate force setting is essential for safety and achieving the best results with patients. With the switch in the down position, the low setting is achieved. Our low setting produces about 100 newtons, which is lighter than the spring-loaded devices that are on the market. We like to use this setting for the upper cervical region for pediatrics and for excessively tender areas of the spine and extremities. With the switch placed in the middle position, the medium force setting is selected, producing about 200 newtons of peak force. We find this ideal for adjusting the thoracic spine, lower cervicals, as well as many of the extremity joints. With the switch in the up position, the high force setting is selected, which produces about 400 newtons of force. The high setting is suggested for use in the lumbar spine and sacroiliac joint when more force is needed to accomplish the adjustment. Of course, force settings will vary according to the size and condition of the patient. It's recommended to use a lower force setting for smaller patients. And for those patients that are more symptomatic or overly tender, you should select less force for their comfort. As I've said, always set the force on the device prior to applying the instrument to the patient. Be sure to test the force setting in your own hand even, before applying it to the patient's spine or extremities to ensure that you've selected the right force or the force that you're intending. Our research has found that the thrust of the Impulse IQ is twice as fast as the spring-loaded devices commonly used by chiropractors. And by adjusting at the right frequency, together with the extreme speed of the thrust, it helps move the vertebrae easier in accomplishing the adjustment. The thrust is also faster than the patient's natural tendency to tighten up and resist the force of the thrust. Easier on you and easier on the patient. Just more advantages of instrument adjusting. Like Impulse, Impulse IQ is equipped with an electronic trigger that interfaces with an internal optical sensor that enables you to perform single or multiple pulse thrusts for accomplishing the chiropractic adjustment. If you choose to deliver a single thrust with IQ, simply preload the stylus and the red LED will turn green, indicating that proper preload has been achieved, and pull the trigger once and release. This will cause the instrument to fire once. Pulling the trigger and holding it down causes the instrument to enter the multiple pulse train mode, and it's AutoSense technology, where multiple pulses will take place. Our research has shown that multiple pulses can increase the vertebral motions by over 25%. Thus, in areas you desire to create greater mobility, engaging the multiple pulse mode will enable you to create more vertebral motion that is capable with a single thrust. Please note that over-adjusting is more work for the doctor and can cause excessive soreness for the patient, as well as can shorten the lifespan of the instrument. So in most cases, when the instrument beeps once, you can move on to the next area. Single stylus applications include chiropractic adjustment of body rotation subluxations or those segmental dysfunctions with lateral flexion components. In essence, impulsive thrusts utilizing the single stylus application provide axial rotation motions coupled with lateral flexion of the functional spinal unit as the single stylus contacts unilaterally on the side of the spine. In patients with unilateral pain and neuromuscular involvement, this will necessitate the use of the single stylus. Cervical and lumbar dual styluses can be interchanged with the single stylus, thereby contacting on both sides of the spine simultaneously. The application of the dual stylus is used for accomplishing greater posterior to anterior directed vertebral motions. Dual styluses are often used in addressing hypolordosis or kyphotic spinal configurations, or retrolisthesis subluxations, as well as for patients with pain or restriction in sagittal plane motions such as flexion extension. Dual styluses also give you more control during the application of multiple impulse thrusts as opposed to contacting on a spinous process with a single stylus. We discussed this more in our seminars and in our 4-DVD box set of the technique application in the Neuromechanical System DVD. I hope this video has been helpful for you to better understand impulse IQ. I'd highly recommend that you take one of our Neuromechanical System seminars and fully review our 4-DVD box set that we put together to learn more about patient care with the instrument. For more information, or if you have any questions, please don't hesitate to contact our office by phone or by email. I hope you enjoy Impulse IQ as much as we've enjoyed developing it.